Hello everyone, this is Raghavendra Prasad and welcome to this session. The topic is turbines, which is a part of Elements of Mechanical Engineering subject syllabus, Module 2. Before we discuss about turbines, let us see what is prime movers. Prime mover is a mechanical device which converts energy obtained from natural source into mechanical energy. Natural source means like water, steam or gas or product of combustion can be converted into mechanical energy, or we can say rotation of the shaft with the help of prime movers. So some examples are given as steam engines or steam turbines, gas turbines, ice engines, etc. Steam engines are used in steam locomotives. So these steam engines utilize the heat energy obtained during the combustion of the coal or the fuel, and this heat energy will be converted into mechanical energy. That is the rotation of the wheels of the locomotives. That is how the locomotive moves. Whereas steam turbines are used in nuclear power plants, thermal power plants, where steam is allowed to glide over the turbines so that turbine can rotate. Whereas gas turbines are used for two purposes. One is power generation, it is by using stationary gas turbines, and also it can be used for another purpose, that is in aircraft as jet engines, which uses some fuel like aviation fuel, which will be burned inside the engine, and the energy of combustion will be utilized in order to produce the thrust force which is required for the movement of the aircraft. IC engines can be seen almost in all on-road vehicles, which are used to convert the fuel energy into mechanical energy. Diagram what you see here is just an example. We can call it as a turbine. So turbine is a machine in which a rotary motion is obtained by the gradual change of moment of fluid. Now here the fluid momentum means the fluid is moving at certain velocity, and it has some energy present in it. So this energy is changing and the velocity is also changing, and because of that the momentum of the fluid will change. If the fluid is stationary, that is only potential energy is present, the energy cannot be converted into mechanical energy. Whereas if the fluid is flowing, it has motion, then the velocity energy and the kinetic energy and the pressure energy present in the fluid can be converted into mechanical energy with the help of turbines. Are broadly classified into four types. One is steam turbine, which uses steam which is produced by heating the water beyond boiling point as working fluid. Second one is water turbine, which uses water which is flowing at very high velocity and pressure, or you can say with very high kinetic energy and pressure energy. One is gas turbine, which uses the energy present in the product of combustion, or the product of combustion of any fuel which is burned. And the last one is wind turbines, which uses the energy, that is velocity energy and the pressure energy, velocity energy and the pressure energy present in the wind. So there is a difference between air and wind. Air is stationary and wind is air which has some velocity energy present in it. That means it is moving. Applications. So turbines can be used for two applications. One is for the production of electricity or electric energy generation, and second one is to drive some other devices like pumps or fans or blowers or compressors, etc. Turbo machine. So turbo machine is a device which is rotating always. It either produce or consume energy. Power producing turbo machines are turbines, whereas power consuming turbo machines are pumps, which is another topic in the same module. The turbo machine consisting of four parts. First one is the rotating element, which rotates at a very high speed, and this rotating element also called as rotor and runner are also called as impeller. So if it is a power generating turbo machine, then we can use the word rotor or runner. If it is a power consuming one, that is in case of pumps, we can use the word impeller. Whereas the second part of turbo machine is stationary element. It is either a guide vane which guides the fluid towards the rotating element, or it is a nozzle or any passage. The third one is input or output or inlet and outlet ports. Now let us take a simple example in order to understand the working principle of a simple turbo machine. Let us assume that water is entering the turbo machine through the inlet. As soon as it enters through the inlet, it initially comes in contact with the stationary element, which is actually housed inside the housing and connected to the housing surface from the inside. Now the stationary element is not moving, it can only guide the water towards the rotating element. So the water now moves towards the rotating element with the help of stationary element. And since the rotating element is placed or fixed on the shaft, which is also a rotating element, as soon as the water glides over this rotating element, it starts to move and which in turn rotates the shaft. Once the work is done, the water leaves the turbo machine through the outlet. Hydraulic turbines are also called as water turbines. So water turbines are prime movers which convert the kinetic energy and potential energy present in the water into mechanical or rotary motion of shaft. So these water turbines uses water which are moving at very high velocity and pressure. Hydraulic turbine classifications. So based on the action of water, this hydraulic turbine can be classified into impulse turbine and reaction turbine. If you see the slide, in this there are two diagrams are there. First one is impulse turbine, and in impulse turbine we can see there is a rotating wheel with the buckets, and there is a stationary nozzle which supplies water in the form of jet at very high velocity. The water when impinges on the bucket or the blades of the turbine, the blade moves and the turbine rotates in counterclockwise direction. Now you can see here the water is in the form of jet and it is not filling the cabin or it is not in direct contact with all the blades at a time. Whereas in case of reaction turbine we can see there is a casing or a cover inside which the fixed blades, rotating blades and the shaft are placed. There is the inlet and outlet and the direction of water flow is shown from top to bottom. In this case, that is reaction turbine, the water initially fills the cabin or the casing completely so that all the fixed blades, rotating blades and the shaft will be in continuous contact with the water. The water will flow from inlet to outlet at very high velocity. So this high velocity and high pressure water will make the rotating blades to rotate. Second one is based on name of the originator or the inventor. So inventor name is given to that particular turbine. So first one is Pelton Wheel, second one is Kaplan Turbine, third one is Francis Turbine. So third classification is based on direction of water flow. The water flows in axial direction means the flow is parallel to the axis of the shaft, whereas tangential flow means the flow is tangential to the turbine, whereas radial flow means it is radial to the turbine. And for this radial flow, special spiral casing design is required. And the last one is mixed flow. Mixed means the entry is tangential, exit is radial, or vice versa, or you can say entry is axial, exit is tangential, or vice versa. Similarly, entry is axial and exit is radial, or vice versa, like this. Whereas the next one is based on head available. There are three types: high head, medium head, and low head. This head available is decided based on the height of the dam which is constructed in order to store the water. In case of hydraulic turbines, dams must be constructed across the flowing river in order to store large amount of water. If the height of dam is more than 150 meters, then we can say it is high head dams. Whereas if it is between 60 to 150 meters, then we can call it as medium head dams. Whereas if the height is less than 60 meters, then we can call it as low head dams. Next, based on the specific speed, there are three types: low, medium, and high. Specific speed is inversely proportional to head available. If the head available is small, the amount of water required is less. Hence, the specific speed will be low. Whereas, if the head available is low, then large quantity of water is required. Hence, the specific speed will be high. for the turbine. Sixth point is based on plant capacity. So there are three types are there. First one is mega plants or major plants which produce power in megawatts. Whereas second one is micro plants which produce power in kilowatts. Whereas the last one is nano plants which are small scale plants which also produce power in a very small scale in kilowatts normally. So last one is based on the position of the shaft, that is shaft position. So there are two types are there. One is horizontally positioned turbine and second one is vertically positioned turbine. So Pelton wheel, which is the high head low specific speed turbine, is horizontally positioned, whereas Kaplan and Francis turbines are vertically positioned. Pelton wheel. So you can see the diagram here shown. It is the front view of the Pelton wheel. So you can see different parts of Pelton wheel. One is the Pelton wheel casing, which is made up of bricks normally, and inside this casing we can see Pelton wheel with Pelton cups. Pelton wheel is a disc type of wheel, and on the periphery of this wheel or disc you can find Pelton cups which are mounted with the help of bolt and nuts or with the help of rivets. You can see there is a pipe with a nozzle at the end, and there is a needle in order to control the flow rate. Nozzle is actually a convergent type. Its diameter is decreasing or area of cross section is decreasing, so that the pressure energy can be converted into kinetic energy when the water leaves the nozzle end. So the water will be in the form of jet impinges on the Pelton cups and make the Pelton wheel to rotate. Now here the water from the dam enters into the penstock, which is a large diameter long pipe, and water comes down and enters into the powerhouse, and before it comes out from the nozzle, the water pressure energy will be converted into kinetic energy fully. Now there is a needle which is actually controlling the flow rate. If you move the needle towards the nozzle end, the area of cross section will reduce. That will reduce the flow rate drastically. Whereas if you move the needle in the reverse direction, that is in the backward direction, the area available will increase for the flow, and because of that flow rate will increase. Flow rate is also called as discharge, and the unit is millimeter cube per second or meter cube per second. So Pelton wheel is a high head tangential flow horizontal shaft impulse turbine. So it is a high head, that means the head capacity must be more than 150 meters. That means height of the dam must be more than 150 meters. And it is tangential flow. You can see in the diagram the flow of water is perfectly tangential to the shaft. Whereas it is a impulse turbine, that means the casing is not completely filled with the water. Only a jet of water will be in touch with some blades only or Pelton cups only. Horizontal, also it is a horizontally positioned turbine. You can see the shaft is horizontal, and it is having a very low specific speed. Pelton cups are specially designed cups or blades. You can see in the diagram. So this Pelton cup split the water into two pieces or two portions, and each portion of the water will apply same amount of force or pressure on the blade. Because of the special design of this Pelton cup, the loss of water during the flow can be reduced to very minimum value. Turbine. So Francis turbine is a reaction type of turbine. That means water will be filled in the casing all the time. That means all the stationary and moving blades will be in continuous touch with the water always. Unlike in case of impulse turbine. So we can see here two diagrams are given. The left side one, that is the first diagram, is the top view, and the right side one is the sectional front view of the Francis turbine. So Francis turbine, when you watch from the top, we can see three main parts, major parts. One is the spiral casing. Spiral casing is the one in which the diameter of the pipe from inlet to outlet will drastically decrease, continuously decrease, in order to change the direction of water towards the center of the spiral casing. Second one is guide wheel with guide blade. So guide wheel is a ring which is a fixed one and to which guide blades are just pivoted so that we can move or tilt or we can say swing that guide blade with respect to that pivoted point. So there is a minimum and maximum angle between which we can twist or we can tilt the guide plates. So guide blades are used to direct the water towards the runner blade. So runner design is shown in the next diagram here. So on the right side you can see it is a runner of Francis turbine which is made up of single piece without using any welding or riveting or bolt and nuts. It is a single piece made by using casting process. Along with that we can see on the left hand side that is there is a dam, there is a pipe and there is a powerhouse. So from the dam water enters into this pipe and enters into the powerhouse. This powerhouse is divided into two pieces. The bottom portion houses the Francis turbine which is the vertically shaft turbine, and above that there is a generator in the second cabin, that is the top cabin of the powerhouse, and there is a tail race. After the work done by the water will discharge into tail race and from there it will goes to the river. The water through the inlet enters into the spiral casing, and when it enters into the spiral casing and as it flows towards the center, it will, because of the shape of the spiral casing, it will direct towards the guide vane. So guide vane or guide blade direct the water towards the runner. So runner is actually positioned vertically. Axis of the runner is perfectly vertical. So what happens here is, so the water with a very high velocity and pressure impinges on the runner blades and moves the runner. And since the shaft of this runner is directly connected to the generator above it, so generator also rotates and the power is produced. After the work is done, the water will enters into the draft tube, which is positioned exactly below the uh, runner. It is a cylindrical tube. So tube will help us in equalizing the pressure, because what happens is water when it enters into the spiral casing and runs between the guide blade and the runner blades, the pressure will decrease and falls below atmospheric pressure, and because of that the there may be chance of back pressure acting on the blades and it will reduce the speed of the runner. So in order to avoid that, draft tube are used. So draft tube will convert the kinetic energy which is not utilized by the turbine into pressure energy. This will increase the pressure and equalize with the atmospheric pressure, and because of this the water will leave easily from the turbine and enters into the tail race. So Kaplan turbine in design looks somewhat similar to that of Francis turbine, except one important thing, that is the center Kaplan wheel. The design of a Kaplan turbine, if you see in the second diagram that is on the right hand side, resembles propeller of the shaft. So it is also called as propeller turbine. So Kaplan turbine is also called as propeller turbine because of this shape of the blade. So in the next diagram you can see here the propeller of the turbine or Kaplan turbine. It is in actual size. Whereas on the left side we can see there is a plant, there is a dam and water which is filled in the dam, and it is entering into this Kaplan turbine and it is flowing out through with the help of draft tube into the tail race, and there is a generator which is exactly above this turbine which is used to produce power or to convert the mechanical energy into electric energy. So here also working principle of this turbine resembles the Francis turbine. Water through the large diameter inlet enters into the spiral casing. Then the guide blade or guide wheel guide the water towards the runner blade, and the runner rotates.